Hello guys, good evening. Can you hear me?
Yes, sir.
Yes, sir. Good evening.
Good evening. Okay, so we'll wait for a while, let others also join, and then we'll start, okay?
Good evening, sir.
Good evening, Aryl. Hello. Hello.
Yes, sir.
Okay. So what have we done last class?
Williamson ether synthesis.
What?
Williamson ether synthesis.
Williamson ether synthesis. Okay. So that is the chemical properties of alkyl that we were doing, right?
Yes, sir.
Okay. Okay. So we have discussed about substitution reaction, correct?
Yes, sir.
Right? I told you that SN1, SN2, and if you want to get more into substitution reaction, then I share the video with you that I've already recorded. Okay. but mostly SN1 and SN2 we have already discussed. Okay, what is SN1 and SN2? Okay, so the next reaction we have is dehydrohalogenation reaction. Okay, don't write down dehydrohalogenation reaction. We'll see elimination reaction and dehydrohalogenation reaction is the type of elimination reaction. Okay, means it is an elimination reaction also. It shows alkyl halide. Okay, we have discussed about substitution reaction in alkyl halide. Now it is elimination reaction. Okay.
Sir,
Yeah.
are you sharing the screen right now?
No, wait.
Okay, sir. No problem.
Okay, fine. So, could you see the screen now?
Yes.
Okay. So, write down the heading. First, we'll discuss elimination reaction. And why we are discussing elimination reaction here? Because alkyl halide, like we have discussed, it shows substitution reaction. It also shows elimination reaction here, right? So what is an elimination reaction? Obviously, elimination reaction in which some molecules get eliminated, right? So for example, one general reaction if we discuss, carbon, there's a leaving group here, and then hydrogen present here. When you heat this compound in presence of a base, okay, then the product that we get here is C double bond C plus BH. Oh, I should write HB. B negative, H positive we have. So it's better to write HB and leaving group goes out. Okay. This is an elimination reaction. So what is required for an elimination reaction? This is alpha carbon, you see. The carbon which has leaving group, it's alpha, and this is beta. Okay. So alpha carbon contains leaving group and beta carbon contains at least one hydrogen. At least one hydrogen. That is the condition for elimination reaction. Okay. Now, what are the characteristics of this reaction? The first one is, you see, 2 sigma bond, this sigma and this sigma converts into 1 pi and 1 sigma. Right, here 1 pi bond forms and here 1 sigma bond forms. So what we can write, 2 sigma bond converts into 1 pi and 1 sigma. Hence, the reaction is what? Endothermic or exothermic?
Endothermic.
It's endothermic reaction. Because 2 strong bonds are breaking and 1 weak bond is forming, right? So more energy we require here. to break this strong bond. Sigma bonds are stronger than pi bond. Entropy change endothermic, it means delta H is greater than 0.
Positive.
Entropy change delta S is also positive since one molecule converts into two molecules, right? More number of product we have. Hence entropy increases. So for spontaneity of this kind of reaction, delta G must be less than 0. And if you see the condition of temperature, that would be, this is positive, delta S is positive. So delta G will be negative at what?
High temperatures.
High temperature. That's why elimination reactions favored at high temperature. ठीक है? Clear है? Understood?
Yes, sir.
Venkat,
Yes, sir. I understood, sir.
how are you?
I'm fine, sir. How are you, sir?
Good. Right? Understood, everybody? Just give me a reply. You can type CLR quickly. Okay.
So 1 second, sir. Writing. 1 second.
Again.
2 minutes. Faster than Maggie. Oh, sigma bond.
Advaita, you there?
Yes, sir.
मैं तुम्हें reply करूँगा, right? I
हाँ.
have doubts. Okay. So
हाँ.
I'm not getting time. That's इसलिए मैं कर नहीं पा रहा हूँ. So
हाँ,
by
okay.
tomorrow I'll send you the reply. Okay.
Okay. Thank you, sir.
Yeah.
Done, sir.
ठीक है. So yeah. Now you see elimination reaction. This also has 3 types of elimination reaction. Okay. Detail में I won't go. I will tell you the important one here. Okay. For detail, again the same thing. What you have to do? The video I'll share for that. Okay. So the first thing here, types of elimination reaction, you write on the heading. Okay, first thing, E1 type, E2 type, then
E3 type.
I knew that.
Oh, of course.
And is it EI, intramolecular, right? This CB stands for conjugate base. Okay, and out of the 4, the most important one is these 2 types of elimination reaction, E1 and E2. Okay, now E1 and SN1 is very similar. Understood, guys? E1 and SN1 is very similar. However, the nature of the reaction is different. One gives eliminated product, other one gives substituted product. But the way the reaction is proceeding, the condition that is required for SN1 and E1 is almost same. Only one difference is there, right? So the first 2 we'll discuss, E1 and E2. Here you see the first type of reaction you write down, that is E1 reaction. E1 reaction is it's again like if I write on the general thing here, in presence of a base, this gives L minus and we are heating it. Why heating is required?
High temperature.
Pi bond. You're forming a pi bond.
Just now we saw that high temperature favors elimination reaction.
Yes,
Okay?
sir.
Okay. What is this? B minus? B minus is the base. This is the base we have. Now the steps involved in this reaction, you see, the first step is the formation of carbocation, like we have formation of carbocation in SN1 reaction. Here also we have formation of carbocation. So how does it happen? You see, we have a leaving group here and one hydrogen at beta carbon. Okay, so the first step is positive charge and this leaving group goes out, right? And the second step is deprotonation, we can say, or attack of base. So you have this molecule, the carbocation, which have here positive charge and H, the base B minus, which we are using in this reaction, it takes this H plus from the beta carbon and this bond pair comes over here. So it forms C double bond C and H plus BH here. Okay. The RDS and the slow step of the reaction is this. RDS, slow step. This one is fast. So formation of carbocation is the RDS of the reaction. Okay.
Once again, they're writing last step
So
now.
here rearrangement also possible.
Plus goes to the next. Why?
What?
Why will rearrangement be possible? Sir, it's anyway secondary, you know.
No, it's
I mean,
possible
unless
then.
if it is.
If possible
Oh,
then.
okay, okay.
Done?
Done, sir.
Okay. Now, could you tell me one thing, that this carbocation that is forming here, why don't this base here, right, the base that we are using, why don't this base behaves as a nucleophile and attack onto the positive charge carbon atom and gives nucleophilic substitution reaction? Is that possible?
No, sir, it's not possible.
Why?
Otherwise, you would have told us.
See, the point here that you have to understand is that the condition of nucleophilic substitution is also there. You see that? Means this base, it may attack onto this carbon also, right? You should ask me this question. Why this base is taking this H plus? Why not this base behaves as a nucleophile and this attacks onto this positive charge carbon atom? Correct? Yes.
Yes, sir, should have asked that.
Yes. So the point is, this has tendency to attack over here, and that is the same step we have in SN1 reaction. SN1 reaction also involves formation of carbocation in the first step, and the second step, attack of nucleophile. Okay. Right. So here you see everything is exactly similar to that of SN1 reaction. The only difference is here the temperature is little high. means the temperature required for SN1 reaction. Here we have more than that. The temperature we are using here is more than that. So at higher temperature, the tendency is more for what reaction? Elimination reaction. Okay, and hence this base takes this H plus and forms eliminated product. Another thing is the nucleophile that we take here, or the base here that we take, it is comparatively weak nucleophile we consider. Because if this nucleophile is strong, if the base is strong, then it behaves as a nucleophile and it attacks onto this carbon atom. Right? So weak nucleophile plus high temperature gives you elimination.
So 1 second, we always take weak base. Sir, so and if the base was strong, then it will be nucleophilic substitution, sir.
Yes.
Okay.
See, actually, देखो बात क्या है कि we have discussed कि SN1, SN2 reactions are comparative reaction, right?
Yeah.
In any reaction, these two reactions are competing each other. Now, depending upon the conditions, solvent, etc., one will be favored, and that gives the major product. So similarly, SN1 even also
Yes, sir.
competitive reactions.
Even E2 and all.
Yeah, suppose in some reaction SN1 is taking place. Now, if in the
Yes,
same
sir.
reaction you are increasing the temperature, then instead of SN1, chances of elimination will be higher there, since you are increasing.
Oh, okay.
Right. So all these
Yes,
SN1,
sir.
SN2, E1, E2 are competitive reactions. Slightly you change
Okay, sir.
the mechanism of the reaction.
Oh, that's why temperature is important in reactions nowadays.
Yes. So what happens when you have these kind of questions, like when you say that this is SN1, this is SN2, you have to keep that in mind, right? Like this, for example, we have this reaction, no, halide exchange reaction, Stephen's reaction. We use NaI acetone for that purpose.
Finkelstein.
Finkelstein reaction.
Yes, sir.
Right. So Schwartz
Yeah,
reaction.
that guy.
Right. So all this Finkelstein reaction and Schwartz reaction are SN2 reaction. So that you should know.
Yeah.
These are SN2. Right. But again, there are 3-4 factors which determines the mechanism of the reaction, and those are temperature, solvent, like leaving group availability plus nucleophilic nature. All these 4 factors are there. Okay. So anyways, so this point we have just
Yes, sir.
understood, E1 and SN1 reaction are competitive reaction again. Characteristics of this reaction you write down first. The first point, the rate is Venkat, you mute yourself. This is the rate. Here also, like SN1, the rate is directly proportional to stability of carbocation. It is also directly proportional to leaving group ability. Correct? Okay.
So what exactly is K here? Like K is, sir?
What?
What exactly is K here? Like
K is a constant. Don't think about it. Okay. It's a constant. We'll discuss
okay,
this
sir.
expression. This we call it as rate law expression, RLE. This is rate
Okay,
law
sir.
expression RLE. We'll discuss this in chemical kinetics.
Oh, okay, sir.
Okay, anyways. Order of the reaction is 1 because here we have 1 power, order is 1, and hence it is even reaction. Next one, formation of carbocation. Formation of carbocation, and when carbocation forms, rearrangement is also possible. Again, next thing, weak nucleophile preferred. Okay, the solvent that we need here is polar protic solvent. Polar protic solvent. Next, one note you write down. SN1 and E1 reaction SN1 and E1 reaction has close competition has close competition in any reaction if the temperature is higher then it favors elimination reaction. Okay, now you see the first step
Sir,
of
can
this
you repeat
reaction.
the last point? I couldn't hear.
If the temperature is higher, then it favors elimination reaction. Now you see, if you have this molecule H, and in presence of a base, this gives CH, C positive charge on it, and leaving group goes out. Now you see this reaction, after this we can have SN1 or we can have E1. E1 we can have SN1, and this is the only difference we have. This is the only thing you have to consider in SN1 and E1 reaction, right? The nucleophile here, Nu minus, and the base here, B minus. Okay, first of all, the base is, weaker nucleophile should be there for elimination, and since elimination reaction favors at higher temperature, so for this elimination we need to heat this reaction also. So if you're not heating it, mostly the chances is that we get a nucleophile here. Okay, and if you heat this, then what happens, it takes the alpha hydrogen and forms this product, alkene. So this is not a positive charge, which you don't have here. By mistake I have written this. So this is what? This is an eliminated product and this is substituted product. Just a second, Venkat. Okay. So this is the product we get. Here we have a nucleophile attachment to this. Okay. Now the important point here you see is the temperature range. You see, if you have temperature if the temperature is low, it favors SN1. High, it favors E1. This is the two competitive reaction we have. Okay. Low means the temperature should be less than 25 degrees Celsius. And E1 is greater than 50 degrees Celsius. Right? And this temperature value that I have given you, it is only for alkyl halide. Okay, this is for alkyl halide. In between these two temperatures, both elimination and substitution possible. Write down. When the temperature is between 25 to 50 degrees Celsius, it favors both elimination and substitution reaction. Clear? Done?
Yeah.
Okay. Now you see the few questions and tell me how many products possible here. With the mechanism of reaction. What mechanism is possible? Same thing. Same reagent we have. Okay, try this. I'm just coming in a minute.
Is it 2 for the first one, guys?
What?
Hello?
What did you tell?
2 for the first one, bro. Is it 2 for the first one? Rain.
Yeah, what it's elimination, Noda.
Yeah. I mean, that's obvious, but is it 2 for the first one? 2 products.
Yeah, obviously no.
Okay.
Mute your video first, Venkat.
Oh, sorry. Must have switched it on when I wanted to switch on the mic at one point.
Okay, done.
Last one, sir.
Try. First one, what is the mechanism of reaction?
E1.
And why E1?
Temperature 80 degrees Celsius.
How many product
And
possible?
2.
Only 2.
Yes, sir. I mean, are you considering isomers also? I just wrote the main structure, sir. I didn't consider isomers.
Yes, we'll consider isomers also.
Abbe yaar. Say without isomers, sir, please. Too complicated.
It's not.
3.
Okay, sir.
So first of all, you have to write down the carbocation, right? The intermediate is carbocation, which is this. And then what happens? Removal of H plus from the beta carbon.
Alpha hydrogen.
So that carbon
Beta
could be
hydrogen.
this or could be this.
Yeah.
One possible product is this. Another possible product is this. Correct? And one more will be the cis of this one. For this, cis trans both will be.
Oh.
Venkat, mute. We get a positive charge here. Then rearrangement possible to get more stable carbocation. So we'll do 1,2 hydride shift
You can go only up, no, sir.
and we get this.
Oh.
And then we have ring expansion. We get this. Just a second. Positive charge will have over here. We'll have somewhere here. Then we have 1,2 methyl shift. And then we have attack of Cl minus gives you this. Sorry. Elimination of H plus gives you this. So one product is this. Another product is this. Do we have any other product possible?
No, sir. I don't think so.
Why no?
There. Oh yeah. But under this, they know the same. Okay. Sir,
So
two
here,
doubts.
hmm.
In the first step only, why did this one carbocation shift have to take place? I mean, that's also tertiary. That's also tertiary, sir.
How many alpha hydrogen we have here?
4. How 5? 1, 2, 3, 4. Ah, 5, 5, 5, 5. That one. Up one also.
How many alpha hydrogen we have here?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. 7, 7, 7.
3 plus 3 plus 1.
Yes, sir.
So more alpha hydrogen, more stable.
Or more hyperconjugation.
Yes. And then we have ring
Then,
expansion.
how do we know that ring expansion occurs, sir? I mean, it goes from 5-membered ring to 6-membered ring. I know that's more stable, but like, how exactly do we draw
Condition
such
also I
things?
have discussed in the class, GOC.
The torsional strain and all, no, sir.
No, condition I have discussed that ring and the adjacent carbon of this ring. If the carbon has positive charge, then ring expansion possible. GOC revise karo ek baar.
Yes, sir.
You do not revise
Doing.
it, but this is how you are not getting it. The condition है expansion का. We have a ring and ring का adjacent carbon पे if there is any positive charge present, then ring expansion is there. If there is a positive charge on ring itself, then a contraction is possible.
Oh yeah, now I remember. This one you told in school, yes, sir.
Yeah, so that's what you must keep in mind. After this,
Yes,
again
sir.
you have one methyl shift.
Methyl shift, yeah.
It is 2 degree, this becomes 3 degree now. And after
Yeah.
this, we have H plus removal process.
1 sec, sir. 1 sec, sir. I'll write that in my agenda.
Done.
Almost, sir. Yeah, done, sir.
Okay. Tell me the number of product is the third one.
Sir, officially number of products in the second one is 3, no, sir?
Which one? Third one.
Officially,
Second
yeah,
one.
the number, second one, yeah.
3. 1, 2, 3.
Last 3.
Yes, last 3.
Okay, sir.
Okay. Now here the product is, first of all, we'll get a carbocation which is a resonance stabilized. And after this, H plus comes out. And the only product we get is this.
Yes, sir.
Okay.
Sir, so only one product, no, in this?
Yeah, in this only one product.
Okay, correct.
Now, the next type of reaction we have, that is E2 reaction. E2 reaction is, it basically requires a stronger base than E1 reaction, right? A stronger base than E1. Okay. Write down this base takes H plus ion this base takes H plus ion from the beta carbon carbon and at the same time leaving group goes out. Okay, so here the reaction is, it's like
Sir,
SN2.
can you repeat if you don't mind?
Yeah. The base takes H plus ion from the beta carbon, H plus ion from the beta carbon, and at the same time the leaving group goes out from alpha carbon. Okay. Now you look at the reaction. How does it go? And it is again similar to SN2 type. Suppose we have a molecule, say this one, carbon, carbon, leaving group hydrogen, and we are using a base, and this is a strong base we are assuming, stronger than the base that we use in E1 reaction. So this base takes this H plus, okay, and then this pi bond, this sigma bond has tendency to come over here, and this sigma bond has tendency to go like this. So we get a transition state here, and that transition state is something like this. Oh, just a second. So carbon, we have hydrogen here. Carbon, we have a leaving group. This pi bond is about to break, and this group is about to form. Here we have some base, suppose we have. Okay. So this is the transition state we have. Eventually what happens, it's highly unstable, and eventually what happens, this converts into this product. BH bond forms and leaving group goes out like this. So this reaction is properties you write down. This is a one-step reaction. This is one-step reaction. Order is 2. Done. One step reaction. Order of the reaction is 2. Order of the reaction is 2. There's no carbocation formation. Done. Order of no carbocation, no rearrangement. It
Yes, sir.
requires.
All
It
1
requires.
second. 1 second. Yes, sir. Till that is done. Till no carbocation formed.
Right. It requires a stronger base. Okay. It requires a stronger base. Stronger base, for example, we can take alcoholic KOH. Strong base. We can take alcoholic KOH. We can also take NaNH2 in NH3. NaNH3. We can also take RO minus Na plus with ROH, or we can also take tertiary butoxide ion O minus Na plus in the solvent, say this one OH. Okay. Now these reactions you see, elimination reaction. Okay, so what happens in this reaction, if you just observe here, this carbon which has leaving group attached to it, this carbon is the alpha carbon, this is the beta carbon. So leaving groups goes out from alpha and H plus goes out from beta. Okay, hence we also call it as alpha beta elimination reaction. So this reaction is also known as alpha beta elimination or 1,2 elimination reaction. Okay, understood this? So all these elimination reactions are also known as.
1 sec, sir. Almost done. Writing the previous one. This one I written. This one I written. No carbocation formed and those other things, sir.
So it's done, no?
No, sir. I've stopped at no carbocation. Then I was listening to whatever you said.
Okay.
That beta and all.
Alpha beta elimination or 1,2 elimination.
Yes, sir.
Okay. Now in alkyl halide chapter, there is a reaction which call it as
Halogenation.
halogenation. This reaction is E2 elimination reaction. E2 reaction it is. Like for example, CH3, CHCl, CH3 and CS3. We're using here alcoholic KOH. What is the product we get? Can you tell me?
This one. In alkene,
Right on.
right
Yeah,
side, left side
alkene,
more.
CH. Yeah.
Right on the product. Which chapter is going on in school?
So finished this one, alkyl halides. They're starting alcohols, phenols, ethers.
Okay.
So you chill, sir. You chill and do, sir. I like this chapter.
So what?
So spend more time, sir.
We cannot take entire year in the simple chapter.
This is
Okay.
simple.
Yes.
Okay, sir.
Alcoholic KOH and we are heating it. Now, why the reaction is elimination reaction here? First of all, we have a strong base
Oh yeah,
and we are
heating is
heating it also,
specified.
right? So first of all, what we get the carbocation. We get a carbocation here.
2 degree. But then you can do that shifting thingy to make it 3 degree. Correct, no?
यही तो problem.
Sir, no.
Oh, damn. Okay, suck.
This is E2 reaction, and hence no intermediate forms in this reaction.
Oh yes, sir.
Okay. This product, we call it as Setjeff product. This one is
Hoofman. Ah, yeah.
Hoffman. Okay. Setjeff is the more stable, more substituted alkene. Okay. This one is less substituted alkene, right? More substituted alkene is more stable also because of hyperconjugation. Got it? Any doubt?
No, sir.
Quickly, can you tell me the product in this reaction? It is alcoholic KOH and heating this.
So ethene.
Ethene.
And the product is CH2 double bond CH2.
So there has to be some catch here.
No.
Oh, you are simple question. Okay, sir.
Yes. Now, what about this one? Alcoholic KOH and we are heating it. Done?
Done, sir.
What is the
Yes,
answer?
sir.
What
There is
Down
the-
and up.
one
double
possible
bond, sir.
product is this,
Yes, sir.
and another possible
And
product is this.
diagonal thing. Yeah.
KOH. And we have NaNH2. So this one you must keep in mind. This is sp2 hybridized carbon. Hence carbon chlorine bond is very strong here. And it is very difficult to break with the base like KOH, so there is no reaction into this. But NaNH2 is a stronger base than KOH itself. Right? Base. And hence it takes this chlorine and it forms CH triple bond CH, which is ethine. That's why the product is an ethine. The reason why this product forms because NaNH2 is a stronger base than alcoholic KOH, and hence it can take Cl- from sp2 hybridized carbon atom. Correct? Done. Now, one more
Yes.
question you see. Tell me the reaction in this, the product in this reaction. We have CH3, CH, Cl, CH, CH3, CH3. We are heating this with a base like O minus Na plus, and in a solvent like this. What is the product we get here? OH we have here and we are heating it. Yeah.
So now this will be E1 because you are doing polar protic solvent.
Is it E1?
Yes, sir.
No, the base is strong.
Is that strong? There's just some organic metal.
Two only, no, sir.
The two possible product you get here is H2 double bond, CH single bond, CH3, and CH3. And you also get CH3, CH double bond, CCH3, and CH3. More substitute product is Sedzev product,
Yeah, sir.
and this one is Hoffman. So if you take large base like tertiary butoxide ion, tertiary butoxide ion, like this only we write. If you contains large base, then Hoffman is the major product. And this becomes the minor. For minor base, for small base, Sedzev is the major product. For large base, Hoffman is the major product. Done.
1 second, sir. Wait, Madi, sir. So, what exactly is the definition of big and small? Like,
It's not. When you have branch like there, then
Sir,
it is
doubt.
large base. Yes.
Sir, why is the the major product and sets F the minor
See,
product.
actually what happens, how this mechanism is E2, correct? Venkat,
Yeah.
mute.
What? No, I said okay. Anyways.
Mechanism is E2. So क्या होगा? This base is trying to attack onto this alpha carbon, either this carbon or this carbon. Yes.
Yeah, okay.
So if this is a major base and if you try to attack onto this, then this group will provide hindrance because 3-methyl group we also have here. Right, so it has 3-methyl group. Okay, to extract this
Okay,
H plus, the base has to attack onto this carbon atom. Since this produces hindrance with this, that's why the attack on this carbon is very difficult. Got it? And if you compare this carbon, it has 3 hydrogen. There's no limit here. There's no repulsion here. There's no hindrance. So this base can take this
Okay,
H
sir,
plus
got it.
easier than this. That's
Okay,
why
okay.
this part is the major product, this part is the minor product.
Okay, got it, sir. Thank you.
Done.
Yes, sir.
Next reaction, write down. Reaction with metals. Why this is not working? Huh. Reaction with, oh, it's getting better, metals. So write down alkyl halide, in bracket write down 1 degree, 2 degree or 3 degree. Alkyl halide reacts with metal in presence of alkyl halide 1 degree, 2 degree or 3 degree reacts with metal in presence of diethyl ether in presence of diethyl ether in order to have carbon metal bond got it, carbon metal bond. This kind of compound we call it as organometallic compound. Okay, organometallic compound. For example, you see this reaction Rx with Li, solvent is diethyl ether. It is R plus Li minus, or we can simply write RLi plus HX. Okay, alkyl lithium it is. Even if you have Rx plus Mg, okay, Rx plus Mg in presence of diethyl ether,
RMGX.
RMgX, organometallic compound which is commonly known as Grignard reagent.
Yeah, Grignard.
Correct?
Sir, and why one case halogen is staying there, the other case halogen is getting eliminated, sir?
You're asking why Li not inserting between the carbon metal bond, right?
Yeah, basically that.
See, it's Li and magnesium.
Size difference.
Li, you see, Li, the ionization energy is slightly higher than that of magnesium. Okay.
Yes, sir.
So the metal carbon bond that you have here,
Yeah.
that is not stabilized by the ether linkage there. And hence, this metal Li can release electron, right?
Yes, sir.
That in that presence of free electron, the Rx bond becomes weak, and hence the bond
Yeah.
dissociates.
But Li and Mg should diagonal relationship, no, sir. But so shouldn't both have same properties? Like
No,
not all, but some.
diagonal relationship is fine, but it's not like all the properties are same for the metal. Few properties
Yes,
are
sir.
same, right? All properties are not same. So RLI bond is possible, and the energy that we required for this electron to go out, that energy is sufficient to break the carbon halogen bond. Here also what
Oh,
happens?
completely break it.
No, actually, see here what happens. Our magnesium. Let me write it down. Magnesium releases electron. Okay, it forms Mg2 plus and 2 electron. Right. Now, in presence of this electron, this bond breaks. So it forms R minus and X minus like this. Okay. Right.
Yes, sir.
Now this R minus and X minus surrounds magnesium. Mg2 plus, it's surrounded by R minus and X minus. Sorry. R minus and X minus. So it is both this negative charged ion surrounds the positive charged ion here. And other thing, the ether that you have, OR here like that, or this side we have ether. Ether also surrounds the positive charge ion like this. So this entire complex structure is the Grignard reagent, RMGX. Okay, this entire complex structure is Grignard reagent, RMGX.
Yes, sir.
Here what happens, this kind of complex formation is not there in Li. And it can easily replace the X minus ion goes with HX.
Okay,
Right,
sir.
this
Got it.
negative charge is not bonded by the metal like that. Because
Yes, sir. And sir, oh yeah, sorry. Hello.
Yeah, because of the small size of lithium.
Okay, sir.
Hmm.
And sir, is hydrogen bonding possible intramolecular?
Got it?
Yes, sir.
So this is
And
metal. Tell me.
is intramolecular hydrogen bonding possible, sir?
Where?
Like oxygen is also there. Oxygen and diethyl ether. Ethyl group and oxygen here.
This one and what? Where's hydrogen here?
C2H5. C2H5. Diethyl ether.
अच्छा ether वाला hydrogen. No, नहीं उसमें नहीं होगा. C2H5 में we have carbon hydrogen bond ना. So there is no electronegative difference.
Oh, okay, sir.
Bond is
No,
not,
I was talking about oxygen hydrogen.
where we have oxygen hydrogen bond? Tell me.
Not directly, sir, but ethyl in the ether itself. If
Right.
oxygen is getting partially pulled by
But there is
magnesium,
not oxygen hydrogen bond. There is no oxygen hydrogen
Yeah.
bond there.
Oh, okay, sir.
That's why it is not possible.
Okay.
Okay. Now,
Yes, sir.
some of the reaction we have, we call it as reduction reaction of alkyl halide. Heading reduction reaction. Just 2-3 reactions we have. Write down. Most alkyl halides most of the alkyl halides may be reduced either by Grignard reagent or
Sir, can you repeat? Sorry, I couldn't hear.
most of the alkyl halides may be reduced either via or by either by Grignard reagent or directly with metals done. Could you write down one reaction based on this? Just now I have done one reaction.
Yes, sir. That
Did you write down
anything and all, no?
just a second. Grignard reagent or directly with metal. In bracket you write down metal in bracket and usually zinc or with LiAlH4 to produce an alkane or with LiAlH4 to produce an alkane. 3 reactions Rx with Mg in presence of ether. What we get?
Grignard reagent.
Then the reaction of this with water gives you what?
RH plus MgOH twice.
This is one reaction. The another reaction is Rx with zinc and HX. It gives you RH plus
Zn(X2).
This is the product possible. And the third one is Rx, the reaction with LiAlH4. LiAlH4 is a strong reducing agent, gives H minus here, which replaces the X minus and forms alkane.
Done, sir.
Done. Now this chapter is almost done. We'll see some questions and then we'll go to the aryl halide thing. Okay, aryl halide is not that big. We'll see some questions onto that. Okay, so we have just a second. Okay. So write down this product in this reaction. We have cyclohexane and a reaction of this with Br2H nu, you'll get A. Now this A react with alcoholic KOH, you'll get B. The reaction of B with NBS gives you C, and C with alcoholic KOH gives D. What is ABCD? Do this and let me know. Done? Anyone?
One sec,
right.
sir. Thinking of third step.
Yeah, C I'm not getting.
See, the first product A is
Bromination.
the bromination, free radical mechanism, and we get this bromine here. Then alcoholic coverage, this RX with this elimination reaction.
Alkene, cycloalkene, I
You get
guess.
cycloalkene. Cycloalkene with NBS, we know it is N-bromosuccinamide. So allylic position, substitution of bromine takes place, right? So yeah.
Okay. This I forgot.
Alcoholic coverage finally takes with this. And again here what happens? E2 mechanism.
Yes, sir. I guess
We'll get
hexagon only. Psych.
Okay. So this is the what we get. This is D. It is E2. Is it clear?
Yes, sir.
One more question, you see. Single bond is. Okay, now this molecule, here we have CH2Cl, and the reaction of this with AgNO3, product we get here. Venkat, mute.
Muted only, sir. I'm muted.
Harin. Acha, Advaita is
Mute
on.
only, sir. It's Venkat.
No, it's Advaita. Anyways. Fine. So, the product we get here is this one. We have a 6-member ring. This and OH we have here. Write down the mechanism of this reaction, how this molecule converts into this product. Think about it. Done?
One sec, sir.
Done?
Sir, is this the Hunziker free radical mechanism by any chance?
Hunziker?
Yes,
Hunziker
sir.
ke liye we need salt of silver.
Yes, AgNO3 is given, sir.
That is salt of acid. It's the carbon, it's the nitrate.
Yeah.
Okay. So first of all, the purpose of this that we are using, you see this Ag plus makes Cl minus from this, okay, and it forms a carbocation here. We'll get CH2 positive charge. Okay. Now, in this, what happens? Since we have 5-member ring here and 6-member ring here, so ring expansion must require. This pi electron, this bond pair comes over here, and it converts into a 6-member ring, like this. So if I number this here, 1, 2, 3, 4, 5, 6. So numbering will be like this. One has 1 attached with 3 and 2. 1 attached with 2, and this side we have 3, 4, 5, and 6. Like this, the bonding we have. And second molecule, at second carbon, we have one methyl group. And the positive charge will have on the second carbon itself. Now from this, what happens? H2O will take as a nucleophile, which attacks onto the positive charged carbon atom, and it forms this OH2 plus and then minus of H plus. This is the answer.
Yes, I got it. But 1 second, sir. So the first step is ring expansion only, right?
First step is the formation of this thing, precipitate AgCl, that leads to a
No.
carbocation, and then ring expansion.
Okay. 1, 2, 3, 4, 5, 6. It's kind of weird, sir. It's kind of hard. These things you need to know everything, otherwise you can't do it.
That's why when you solve this, when you do some practice, then only you will get it.
Okay, sir. Got it. I should do that now. Then it's like all or none principles. Either you know everything or you know nothing.
One more question.
Yes, sir. Please. Super hard, sir.
You are not, doing the simple one.
Yeah. Okay.
Try this. We have cyclopentane. You know the structure, Venkat, right?
Pentagon. Yes, a little bit hopes I have.
Alcoholic KOH. B. NBS. C. It is aqueous KOH. D. Na. E. And the reaction of C and E gives you F. A, B, C, D, E, F.
Sir, I think I'm done.
Just a second.
But I'm not sure if it's right or not.
Venkat,
Huh?
what does aqueous KOH do?
Aqueous KOH, I'm not sure. I think it substitutes with this somewhere.
Acha, fine.
You said you have done.
Yes, sir.
Then what?
No. Like Advaita asked me one thing. That's it.
Yeah, that I know. But you said no, you have done, and you are saying you don't know.
Yeah, I wasn't sure, but I had a positive idea, sir, of KOH. And after that and all. One second, sir. I'll send you a picture. 1 second, wait, Mari. God, oh, sir. Camera. Send, sir.
Just a second. Okay, fine.
Correct.
No, I did not see you.
Oh, okay, sir. Okay.
Just a second. Let's do this. So let me just check your answer first, and then I'll tell you. Adita, what was your doubt?
I'm not sure what aqueous KOH does.
The aqueous KOH is basically KOH with water, right?
Yeah.
It does not give elimination reaction, but it gives substitution reaction, and hence
Okay.
we'll get an alcohol as a product.
Yeah, right.
Yes,
I was
sir.
guessing.
Correct.
Fine. Yeah, right. Even I got it right.
I told that, no? Yeah.
So,
Sir, till E I got, sir, but F I do. I'm
Yeah,
not.
only F I didn't get. I'm not sure.
fine, I'll do this. A is what? A is we have
That
cyclopentane
pentagon and bromine.
and bromine attached on this. B is alcoholic KOH. So alcoholic KOH gives you what? Elimination reaction.
Cycloalkene.
Cycloalkene.
Cycloalkene, yeah.
See, in this one, the temperature nothing is mentioned here, right? But we understood that it produced elimination reaction. We got this. Aqueous KOH. Oh, sorry. C is what? Now NBS is what? N-bromosuccinamide.
Sir,
Vinylic bromine addition.
yeah.
At
Oh, same
allylic
thing.
position, bromine attached, right? So C is this. For this double bond, the allylic position is this one or this one. So here bromine gets attached like this. This is C. Now what is D? D is this. So we'll get an alcohol here. And if you talk about this E, E will be H plus will get replaced by Na plus, O minus and Na plus. And when these
Yes, sir.
react, what we guess? C plus E.
Remove the Na, remove the Br, you'll get an O, like a bridge kind of thing. Like that. I've written it, sir. You can see.
NaBr forms and these two rings combines.
Yes. Correct.
Got this only.
Except, yes, sir. Check it, sir. Like I've written it a bit shabbily, but it's correct.
What is the last step we have? C plus E.
This only, but I've written the
So what
bridge
is that
curvy,
reaction?
sir. That's that. Forgot the reaction. I know what happens, sir. I'm checking, sir. 1 second. कहाँ था बे? You taught this in hydrocarbon also. I remember this. I asked out also in this. What, sir?
Last class I did this.
Okay. But I remember this from hydrocarbons. I don't know the reaction name, sir.
It is Williamson ether synthesis.
Oh, that RONA and all, right? RO, R dash and all that. You did that Trishul and all.
Okay, done.
Backside attack. SN2 can't take place. That one, sir.
Yes, that one.
Okay, sir.
Last class, last part that we discussed.
Yeah, sir. Now I got it.
Okay, fine.
Now I cannot
Now, so we are
remember.
done with this. Now, quickly we'll see two types of product here, two types of molecules here. Heading, you write down dihalogen derivative. Dihalogen derivative. Just you need to memorize these few reactions here. Not much important, but we just go through once. First one is gem dihalides. What is gem dihalide?
Same carbon, two halogen. Same carbon, halon,
Write
chlorine,
down
chlorine
two
attached.
halogen atom and two halogen atom. Gem dihalides when two halogen atom present at the same carbon. Okay. So for example, the preparation method is we can take aldehyde for this purpose plus PCl5. See, whenever you have PCl5 ka reaction, POCl3 must go out. You get CH2, CH, Cl. Further with HCl, you'll get CH3, CH2, Cl2. CHCl2, not CH2. CH3, C triple bond. If you have unsymmetrical alkyne, in unsymmetrical alkyne, the halogen atom will get attached to the carbon which has lesser number of hydrogen or no hydrogen, like this one, this carbon.
Sir, Markonikov, like Markonikov's brother
Yeah.
or sister. I don't do sexism.
See, PCl5 ka reaction, I told you one thing, that it always gives you POCl3. How to write down this product, I'll show you. What you do, you just write down this CS3, C double bond OH. And PCl5, you write down this way. Could you write like this? Now what happens in this H will goes with this Cl, this CS3 goes with this Cl. Oh, just a second. double bond O we have. So one of the bond here, it takes one Cl, another bond takes another Cl, and this P will take this oxygen. So what we get here, you see, when this reaction takes place, CH3C, the two bond takes two chlorine atom, so Cl, Cl, H plus P double bond O, Cl, Cl and Cl. Clear? So like this, we'll write down the product.
You're basically writing the actual chemical bonding wala structure for PCl final,
Correct.
sir.
So anyone want me to go back?
Me.
Yes, sir.
Copy down.
Sir, how did you know, sir, they'd want you to go back?
Because I went to the next page very quickly.
Oh, I thought you knew us. Done, sir.
No, sir, wait.
Yes, I wrote fast.
Finish.
Done, sir.
Okay. Now, few reactions of this you must go through. I am taking this example CH3CHCl2. Two molecules of KOH, aqueous. If you are taking alcoholic KOH, two KCN. Now look at the product here. Aqueous KOH if you are taking, so this will replace the two chlorine atom and it forms CH OH OH. Okay, but 2 hydroxy group at the same carbon is not at all stable. So this easily goes under dehydration reaction and it converts into an aldehyde. So basically from here, one OH and H goes out like this and forms aldehyde. Always remember this fact that 2 hydroxy group, OH group on the same carbon is not stable. Okay. If you are taking this alcoholic KOH, we know alcoholic KOH gives double bond, right? Unsaturation it provides. Since we are taking this as 2 chlorine atom here, so you end up getting an alkyne.
Okay, ma'am.
Sir, is it like the double bond equivalent which you taught us?
No,
Like a number of chlorine atoms determine whether it will be alkene or alkyne.
no, it's
Like
not.
that.
Not that.
Oh, okay, sir.
It's just, you see, 2 chlorine is taken up by 2K plus, and hence we get 2 double bond here, right? And 2 molecules of H2O also goes out. 2 molecules of KCl and 2 molecules of H2O. KCN if you're using, so all these reactions you can say, these are substitution reaction. Cyanide under hydrolysis, okay, it converts CN into CaOH. And when you heat this dicarboxylic acid, CO2 molecules goes out. This is the final answer here. Minus of CO2. Done?
Done.
Finished, all of you?
Sir, done.
Okay. So all these reactions you have to memorize. So याद रखना है, ठीक है? Always keep one thing in mind. Whenever we have two carboxylic acid group present, and in between the two group, we have only one carbon. Then on heating, CO2 molecules goes out. If only one carbon is there. Okay? So here, when you heat this, one of the CO2 molecules goes out, and this hydrogen get attached with this carbon, and we get this. This we call it as heating effect.
What, sir?
Heating effect of this compound.
Oh, heating effect. Okay, sir.
Heating effect of this. Okay. Anyways, so this is one thing. Now the another reaction we see, that is of vicinal dihalide.
1,2 dichloropropane, for example.
Kamala, are you there?
Yes, sir.
Ashwin, are you getting it, Ashwin? Okay. Where is oh, that guy is his name. Suyog, yes.
Sir,
Yeah, are you getting it?
sir, I had gone out, sir.
Where?
Sir, I had just gone 15 minutes kitchen to eat something.
Achha, fine. No issue. We'll share the recording, don't worry.
Okay, sir.
Correct. Shalini, are you getting Vidyuta? Are you there? Shalini, Vidyuta, you there?
Yes, sir.
Niyati, what are you doing? Vidyuta is not there, I guess.
Sir, I'm also there.
Okay. Chalo, ठीक है. So vicinal dihalides. Okay. Vicinal dihalide is two halogen atoms are present at the adjacent carbon atom. For example, if you look at this reaction CH2 double bond CH2, the reaction with Cl2, it gives CH2Cl and CH2Cl. This is vicinal dihalide. Two halogen atom at adjacent carbon. The reaction of diol with two molecules of PCl5, it convert this into CH2,
POHCl3,
CH2Cl,
POCl3 plus H2.
CH3 plus HCl.
HCl. Why? How HCl, sir?
OH का H from HCl there.
But already the Cls from PCl5 has come on to the carbon chain, no, sir. Like balancing and all you should do.
So just a second.
I think that should be H2, sir.
Hmm.
H2, sir, instead of HCl. Not sure.
POCl3. H2O will get here. H2O, yes. Because one oxygen we have taken here, no?
Yes, sir. Other oxygen only.
No, just a second, wait. Five into 2, 10. It's fine. Oh, sorry. So it will be 2 molecules of POCl3 and 2 molecules of HCl. Now it's fine. Total 10 chlorine left hand side, 10 chlorine right hand side.
Yes, sir. Fine, sir.
Now the reaction of this dihalide, see 2-3 reactions just CH2Cl, CH2Cl. When it reacts with aqueous KOH, it forms CH2OH and CH2OH. Again, a substitution reaction. See, again, this thing you observe. Aqueous KOH always gives you alcohol. Right? Again, if I use here alcoholic KOH, what it should form?
Alkene. Ethene to be more. Huh? Oh, 2Cl2 are there. Correct, sir. CH.
Wait. This is not correct. Both chlorine atom is coming out, no? So we'll get here H
Yes.
triple bond CH. This is the product we get. This reaction is important. KCN 2 molecules of it. What it forms, could you tell me?
Dicyanide thingy.
Okay. Now, when you do the hydrolysis of this, what happens? Cyanide under hydrolysis gives you acid always. CN का COOH में conversion होगा. Okay. Now, when you heat this compound, then minus H2O, water molecules comes out, and we end up getting an anhydride. Plus H2O. Succinic anhydride it is.
Sir, but is it compulsory to add H2O, or can we just leave it as dicyanide?
No. Till here, if you have only KCN, the product is this. Further, if you add H2O, then you'll get this.
Okay, sir.
If you do not add H2O, the product will be cyanide.
Sir, one small doubt.
What?
One small doubt कि इसमें H2O will come out. It will form that. But in the previous one, CO2 came out.
CO2 is coming. I was about to talk regarding this.
Okay.
Actually, like I said, it is heating effect, right? So heating effect में क्या होता है? जहाँ पे भी dicarboxylic acid if you have, थोड़ा सा मैं इसको बता देता हूँ अभी. Suppose ऐसा कोई compound, this is important also. HCOOC, and here we have CH2N COOH. ठीक है? अब when you heat this, ठीक है? When you heat this, यहाँ पे जो product आएगा, this product will be, or the product forms by elimination of water or by elimination of carbon dioxide, or by elimination of both. That depends upon how many CH2 is present between the two carboxylic group. So what has been observed that when N की value 0 and 1 hai, then on heating this, CO2 eliminates. Okay, this you have to memorize. This is the heating effect of this. N की value, if it is 2 and 3, then H2O eliminates. N की value, if it is 4, 5, or even it is more, mainly 4 or 5, not more than that, then CO2 and H2 both eliminates. This is the heating effect. So now that molecule that I have written is this, CH2 C double bond O, OH. Or this is like this, CH2 C double bond O, OH. Since two carboxylic acid group we have here, and both group are separated by 2 carbon atoms. So this is the condition, yes or no, Aditya? Second wala condition.
हाँ.
So when you heat this, तो क्या होगा? This this OH and this H comes together, goes out as H2O, and forms an anhydride, which is C double bond O, oxygen C double bond O, CH2. This is the reaction.
So could you please go back, sir?
Okay, sir.
Advaita, got it?
हाँ sir, understood.
Okay. So these 3 points you have to remember.
Sir, can't see the things in middle.
What?
Like after alcoholic AOH.
What?
After alcoholic AOH, I can't see what's written behind it, sir. Yeah, awesome. Yes, sir. Potassium cyanide. Done, sir.
This you have done?
Done, sir. Written.
Okay. The next one you write down, chloroform.
My favorite.
Why? What is the formula?
CHCl3.
Your favorite, and you do not know the formula properly.
I know, sir. I know. I told you, sir. Correctly.
See, the preparation of chloroform can be done by three ways generally. Okay. First method of preparation is from ethanol. Again, here there is no mechanism in all. Just you have to remember the method of preparation. Ethanol, to prepare chloroform from ethanol, what we do, we take CaOCl2, and this we allow to react with water, hydrolysis of this. This gives you Cl2 and calcium hydroxide CaOH whole twice. Now in the second step, the ethanol C2H5OH reacts with Cl2. This is an oxidation reaction. So it forms CS3CHO and 3 molecules of HCl goes out. Third point, third reaction, this acetaldehyde CS3CHO reacts with chlorine again and it converts into Cl3CCHO plus 3 molecules of HCl. This molecule Cl3CCHO, we call it as chloral, right? Now the reaction of chloral with this CaOH whole twice, right? So write down the next step, dehydration of chloral with CaOH whole twice. So you see the reaction here, CaOH OH plus we have 2 molecules of this chloral, this molecule Cl3CHO, Cl3CCHO, and when these two reacts, it converts into a product which is nothing but a chloroform. So this forms, we'll get a chloroform, another molecule of chloroform. So you need 2 molecules of CHCl3 plus we get HCOO2. This is the preparation method from ethanol.
Sir, can we just make ethanol to ethene, then hydrogenate it, and then keep halogenating it?
Theoretically, you can say, but practically, you have to see that what kind of problem you get in this method. Okay, maybe.
Okay, sir.
The other things, the cost effectivity.
But sir, in practical, we use it only for one purpose, right? And in that, even if little bit is there, you can just chalta hai, no, sir. Little bit also you show the person will fall unconscious. So it doesn't matter if other products are there.
Not coming properly.
Is it fine now, sir?
Go ahead.
Like for practical purpose, sir, I mean, not much is required, right?
Yes.
Not much of chloroform is required. Little bit also will go 1 gram, 2 gram and all. So we can just do that. I mean, it might not give 10 kg yield and all, but the chalta hai, no, sir, 1 gram, 2 gram, still that fellow will fall unconscious.
It's not like we cannot do that. See, again, the method that we all is the method which is given in the book. It is a trial and tested method. And
yes, sir.
Only use that method which is easy to carry out in the lab, right?
Yes, sir.
Other method also you can use, but what problem you will get, that we have to see when you
okay, sir.
This plus this gives this. That way you can say. But
yes, sir.
Actually, what happens, that is the the course of observation.
Okay, sir. Yes, sir.
Okay, all of you have done this?
Almost, sir. Let's see.
The question into this is not that only 2-3 reactions you have to see. Now, the another one is, like I said, from acetone. From acetone, again we'll do the hydrolysis of CaCl2 and we get Cl2 plus CaOH whole twice. Now acetone is CS3COCS3. This reacts with Cl2 and it forms Cl3CCOCS3 plus HCl. 3 molecules of HCl. Now again this molecule reacts with calcium hydroxide. It's a similar reaction. Product here again we can write similar way. This chloroform, 2 molecules of CHCl3 plus salt of acetate. Write down next point. Pure form. Write down pure chloroform. Pure chloroform is obtained by the action of NaOH and chloral hydrate. The action of NaOH and chloral hydrate. So the method of preparation of pure chloroform is chloral hydrate is this Cl3CCHO dot H2O plus the reaction with NaOH gives chloroform HCOONA and H2O. So this is the pure form of chloroform we have, and hence this reaction, this method is the most important one. They can ask you by which method we can obtain the pure form of it.
Sir, is chloroform for sale?
What?
Do we get chloroform for sale, sir?
वेंकट तुझे seriously क्यों चाहिए?
Ah, it is there, no? You can get it in the market.
Oh, awesome, sir. Okay.
Why do you want this?
Asking, sir.
Okay, there are 2 reactions of chloroform which are important that you must keep in mind. CHCl3 plus silver. You can easily predict the product of this reaction. Could you tell me? Arey, tell me. It is Ag.
That AG, that Mattidalli. Yeah.
First reaction is this. Second reaction is CHCl3 reaction with 3KOH. What it gives?
OH, and OH.
And from this water molecule easily goes out. It forms
Aldehyde then.
first.
Yeah.
And HCOH ka, the reaction with KOH. So it leads to the dehydration reaction and it forms a salt of. Okay. One last reaction you see.
Last, sir. Why last?
For this chloroform.
Oh.
See, when you have carbon tetrachloride, goes under reduction. In presence of iron as a catalyst, water we also present over there. It forms CHCl3, chloroform. HCl goes out. Now, this chloroform reacts with phenol, OH. This reaction we'll see in alcohol chapter also. I'm just giving you the information. At 65 degrees Celsius, we end up getting this OH and CHO here, and CHO plus 3 NaCl plus 2 H2O. Right? This group, this molecule, we call it as salicylaldehyde.
Eating thing.
And the whole reaction is Reimer-Tiemann. Reimer-Tiemann reaction. Important, this reaction is. Okay, Reimer-Tiemann reaction is important. The reaction of alcohol with chloroform. Done.
1 second, sir.
How was the situation in Yeshwanthpur? People are following this lockdown
Yes, sir.
completely.
No, sir. You can see vehicles on the road though.
Okay. Done. This one, guys.
Done, sir.
Okay. Chalo. Next molecule is iodoform. Have you heard this name, iodoform?
Yes, sir. Iodoform test for anything 2-one, 2 ketone. That one. CHI3.
Iodoform pe, they ask only one question. Only one type.
Iodoform test.
Here. Which of these molecules gives positive iodoform?
Yellow color, 2 ketones, sir. 2 ketone. That one. I know.
No,
this.
what I said, only one type of question they ask. Okay. And what is that question?
Which of the following give positive iodoform test? That is
Positive iodoform.
yellow precipitate.
So if I give you only this information, it is fine.
No, sir. This.
Why do you want to study more?
Oh, okay. It's good, sir. It's very nice. I feel happy now.
I could teach, but you won't remember. No, that is the problem.
Sir, I go back and remember, sir.
Chalo, I was joking. Okay, I will give you a
Okay.
Don't worry. Okay. So
Thank you,
iodoform,
sir.
tell me the formula. It is CHI3.
I3.
Triiodomethane. Chalega?
Yes.
Triiodomethane. So the preparation method of iodoform, there are, see, like we have done chloroform first, and chloroform ka only one reaction is important. The last week here, Reimer-Tiemann reaction. However, the reaction is for phenol ka reaction, but we are using CHCl3 there. So that reaction is the most important one. Iodoform reaction, preparation, other things are not important. Here the only important thing is which of these molecules gives positive iodoform test. 2-3 points we have to take care of. Preparation method, write down first of all. First method is from alcohol, right? So for example, alcohol I am taking ethanol CH3CH2OH. It reacts with I2 and NaOH, 6 molecules of NaOH, and it converts into CHI3 plus HCOONA plus NaI, NaI, and H2O. So here instead of NaOH, we can also use KOH for this purpose. Just to get HCOK, nothing much. The second method of preparation we have from acetone. With acetone also we can prepare this. CH3 C double bond O CH3. The reaction with I2 plus Na2CO3. Na2CO3 on heating, it gives CHI3 iodoform plus the salt of acid, which is CH3COONA plus NaI plus CO2. This is the reaction. Now these reactions are known as iodoform reactions. Okay, done.
Done, sir.
Write down these reactions are called iodoform reactions, and then one note you write down here. Iodoform test is given by, this is the most important one. Iodoform test is given by ethyl alcohol, acetaldehyde, acetone, methyl ketone, acetone, methyl ketone, and the molecule which contains this group. You see here I'm writing it down. And the molecule which contains this group, CHOHCH3, basically secondary alcohol, and the molecule which contains secondary alcohol, this one. Some molecules which gives positive iodoform test are, say methyl ketone means what? In the keto functional group, one side we have methyl, If this group is present in the molecule, it gives positive iodoform test. We can discuss the mechanism of this also, but that is not required now.
Sir, could you just repeat the entire thing about iodoform test? I was writing, but middle I couldn't write some.
What? The note?
Like all the groups, yeah, yes, sir. I note only.
Iodoform test is given by ethyl alcohol.
One second, given by, one second, sir, one second. Ethyl, I'm writing again. Alcohol, acetaldehyde.
Ethyl alcohol, acetaldehyde, acetone.
Yes, sir. Acetone, yes, sir.
Methyl ketone.
Yes, sir.
And the alcohols which has
Yes, sir.
this group present. This one, wait, I'll show. This group present means secondary alcohol.
Oh. Okay, sir.
Okay,
Yes, sir.
fine. So methyl ketone I was talking about. Methyl ketone means one side we have methyl and keto group. This is methyl ketone. Okay. Even if halogen atom present at the second carbon, then also it shows positive iodoform test. Okay, lactic acid. The name also important. Lactic acid shows positive iodoform test because the molecule you see, it has this formula CH3CHOH COOH. You see again CHOH CH3 is present. Okay. Methyl phenyl ketone also shows, means the same thing, the first one. Methyl phenyl ketone, because this is what it is. One side we have methyl and one side we have phenyl. Okay. Pyruvic acid also shows positive iodoform test. Pyruvic acid. Formula is CH3 C double bond OOH. This is pyruvic acid. All these molecules shows positive iodoform test.
Sir, is it only for Cl or for all halogens, sir?
It's only
Second
for
point. Only for chlorine? Oh, okay, sir.
Sir, is this double bond O?
Understood this? Clear? So this is it for alkyl.
Clear, sir.
Okay. This is it for alkyl halide. We'll take a break now, and after the break, we'll start with aryl halide, and we'll finish that also today only.
Okay.
Okay. We'll get back at 6:45. Take a break, just mute your mic, and that is it. Don't leave the meeting. Hello. Hello guys, can you start?
Yes, sir.
Yes.
Okay.
Yes, sir.
The last part of this chapter we are going to discuss is aryl halide. Okay. We know aryl halide is what? It is the haloderivative of benzene. For example, we have a benzene ring and halogen attached to this. This is an aryl halide. Okay, chlorobenzene, bromobenzene, etc. Okay, now the most important point here it is what? If we consider the reactivity of aryl halide and alkyl halide are CH2X. This carbon you see, it is sp3 hybridized. This carbon is sp2 hybridized. And here we have partial double bond characteristics. Yes or no? Yes, do we have partial double bond characteristics here? Because of plus M nature of halogen? Yes. And this kind of resonance is not possible in alkyl halide. This is correct.
Alkyl halide.
Right? So this bond length, if it is L1 and L2, okay. So what we can write, the bond length comparison if you do, so obviously we can write here L1 is greater than L2, right? And
Yes, sir.
the bond CX in aryl halide is stronger than that of alkyl halide. Yes or no? Hence we can say this bond here is difficult to break, and what we can conclude from all this discussion that the reactivity of alkyl halide is greater than to that of aryl halide. Clear? Alkyl halide, hence it is more reactive than aryl halide. And because of this only, if you consider this equilibrium, suppose somehow you dissociate this carbon and halogen bond, then what you get?
Benzene.
You'll get phenyl cation and X minus. And guys, all of you must
Yes,
keep this in mind that a positive charge on benzene ring like this is not stable. Not stable. It is not resonance stabilized. Okay. This ion, positive ion, we call it as phenyl cation. And what we say? That phenyl cation is not resonance stabilized. And hence, this reaction has more tendency to go into backward direction. Again, the dissociation is difficult.
So why is it like that? Why is that very unstable?
What?
Why is phenylketonuria very unstable?
Because it is not in resonance. Venkat,
Double bond, single bond, positive charge.
I will kill you.
Why?
because I have discussed this many times. See this ring.
Sir, 1 minute. Can you go back to the previous slide?
Just a second, Harid. Understand
Okay,
this,
sir.
I'll go back. Okay.
Fine, sir. Fine.
See why these pi electron are in resonance. The reason is what? These p orbital are parallel, right?
I got it, I got it, got it. Remember, overlapping can't take place. Got it.
I'll explain it now. Wait. This has this orbital which loses the electron, right? Which has the positive charge here. So this orbital is not parallel to the other orbitals of carbon atom.
Yes, sir, yes, sir.
This is nothing but the overlapping of orbital, and for that, the orbital must be parallel. Then only the overlap is possible. Right? So since this orbital is not parallel to the other orbital, hence the positive charge on phenyl cation is not at all stable. And since it is not stable, it does not form. So this is also the reason why the reactivity of aryl halide is lesser than to that of alkyl halide. Done.
Got it.
Understood, guys, all of you?
Yes, sir.
But you see, this is one thing, but it is not like all this thing is not always true. It is not like that we cannot do this. We cannot dissociate the bond. Okay. We can do this when there is any powerful electron withdrawing group is present. Okay, so write down that one note you write down. However, when a powerful electron withdrawing group, when a powerful electron withdrawing group is present at ortho or para position, then the halogen atom can be replaced by the nucleophile like OH minus or NH2 minus, etc. So in presence of electron withdrawing group, aryl halide shows substitution reaction, nucleophilic substitution reaction.
So nucleophile like
What? The last one?
yeah, last 4 words, sir.
Last 2 lines were present at ortho or para position. Then the
Halogen atom can be replaced by nucleophile like.
halogen atom can be replaced by the nucleophile such as OH minus or NH2 minus.
Okay, sir. Thank you, sir.
So what we can conclude from all this discussion, that aryl halide goes under nucleophilic substitution reaction. When electron withdrawing group present at ortho or para position. Okay. The presence of electron withdrawing group at meta position has no effect Okay, this is one thing. Another one more point. More number of electron withdrawing group, more will be the reactivity.
Sir, I have a doubt. If you have a strong electrophile,
No doubt.
one strong okay.
Tell me.
Sir, if you have a one very strong electron withdrawing group and two weak withdrawing groups at ortho and para position respectively, which will be more reactive, sir? Like, I mean, I know it's a
One
vague
very
question, but
strong. See, if you have more number of electron withdrawing group, then we'll go with that generally. The case that you are asking,
yes, sir.
it is the, you know, it is experimental actually. You cannot decide in that case.
Okay, okay,
So
sir.
they won't ask you those kind of questions.
Okay, sir.
But mostly what we say, if the reactivity number of EWG is more, reactivity is more. Of same power, basically. That is the understanding. Means one thing you have to fix. No, then you can compare the other thing.
Yes, sir. Yes, sir.
You cannot change all the properties and then we cannot discuss them.
Yes, sir.
Okay. So that's the thing. Method of preparation you write down. See, in method of preparation, just there is very few reactions in this chapter. Okay. The most important one is Friedel-Crafts reaction. Have you heard that? Friedel-Crafts reaction.
Yes, sir.
That is the most important one. So method of preparation. The first method is by direct halogenation. Write down. By direct halogenation. So when you have a benzene ring and it reacts with X2 in presence of anhydrous AlX3, then it gives this molecule, a ring with X plus HX. Where this X is, we can take this X2 as chlorine or bromine. This reaction is only for chlorination and bromination. Okay. We can take, for chlorination, we can take anhydrous AlCl3. For bromination, we can take anhydrous AlBr3. Apart from AlCl3 or AlBr3, we can also take FeCl3 or FeBr3. Clear? This reaction is an example of electrophilic aromatic substitution. अभी तक हम लोग न्यूक्लियोफिलिक सब्स्टिट्यूशन देख रहे थे, है ना?
Yes, sir. Positive charge thingy now.
Electrophilic aromatic substitution. Why we are calling it as electrophilic aromatic substitution? That also we can discuss. अब देखो क्लोरीन लिया suppose Cl2 and AlCl3. This gives AlCl4 minus plus Cl plus. Now this is an electrophile for the reaction, AlCl plus, sorry, Cl plus. So what happens? The benzene ring, here the reaction goes this way. The benzene ring, pi electron of the benzene ring comes over here, and then it takes the Cl plus ion, which is the electrophile. So this comes over here, this attacks onto the Cl plus, and we get something like this. Here we have chlorine, and here we have hydrogen, and this we have the positive charge. Clear? Right?
Yes, sir.
Okay. Now, this compound was initially aromatic in nature. Yes or no? Benzene aromatic tha. When this electrophile attach onto this benzene, this becomes what? Aromaticity has been lost. Aromaticity has been lost. The molecule is no longer aromatic. So this molecule has tendency to gain its aromaticity again, right? Now to gain its aromaticity, this H comes out as H plus, leaving this bond pair of electron behind, and this converts into this compound. H plus comes out, which takes Cl minus from AlCl3 and forms HCl. Anyone has any doubt in this?
No, sir.
Clear? No doubt?
One second, sir.
Done, sir.
Just a second. Once again, guys. Okay. Now, this reaction, the direct halogenation, is possible only for chlorobenzene and bromobenzene, right? Iodobenzene is not possible. We cannot form iodobenzene by direct halogenation, right? So note down this point. Iododerivative, write down. Iododerivative cannot be obtained by direct reaction, by direct reaction, since the reaction is reversible and too slow. reversible and too slow. Next line, to obtain iododerivative, the reaction is carried out in presence of an strong oxidizing agent like nitric acid HNO3 or iodic acid HiO3. Nitric acid or HiO3 iodic acid. These oxidizing agents we use for this reaction. Okay, the reaction, if you see here, it is, we have C6H6 plus I2. This reaction is reversible, forms C6H5I plus HI. Like I said, the reaction is too slow, and hence this has more tendency to go in the backward direction. Hence direct iodination is not possible. But when you have an oxidizing agent like HiO3 or HiO4 present, HNO3 present here, then what does this this oxidizing agent do? It oxidizes this HI into I2, plus will get NO2 and will get H2O also. This is the reaction we have. So whatever HI is forming here, you further this HI is converting into I2. To maintain the equilibrium, this reactant wants to produce HI continuously, right? Because it is continuously, it is converting into I2. So in other words, what we can say, we are removing this HI in the form of iodine by this reaction with oxidizing agent, right? Since we are removing this HI, so this has to produce HI to maintain the equilibrium, Reactivity's principle. Hence, the reaction goes in forward direction. And that is why the oxidizing agent we are using here. Understood?
No, sir. Can you just repeat that once again?
No. देखो क्या हो रहा है, HI यहाँ form कर रहा है, ठीक है? Now
Yes, sir.
this reaction has a tendency to go in backward direction, correct?
Yeah, because it's unstable and all.
Yeah. So to make this reaction to go in forward direction, right? Forward के लिए we are removing one of the product. Leach-Atelier's principle क्या था कि if you remove the product, the reaction goes in forward direction to maintain the concentration of the product, correct? So we are removing HI with the help of the oxidizing agent. Hence, the reaction has to go in forward direction, and hence we get the iododerivative.
Oh, okay, nice. Okay, got it, sir.
That's why the iodination always takes place in presence of an oxidizing agent like HNO3 or HI. Okay, understood? There are
Yes,
two,
sir.
3 more methods of this thing preparation. I'll write it down. The second method the second method is from disonium salt. What is disonium salt?
Azide groups, that NC thing. And
Disonium salt is this benzene ring N2 plus and Cl minus. This is disonium ion N2 plus on the ring. Okay. and it is a salt. So actually, this Cl minus is this. If I write down here to make you understand the structure, it is something like this: N double bond N minus Cl. Sorry, just a second. N triple bond N plus NCl minus. This is the structure here. Diazonium salt is this. We call it as benzene diazonium chloride. Okay, salt of this. Now the reaction of this with different molecules to give the product is the first reaction is the reaction of benzene diazonium salt with CuCl and HCl. CuCl, HCl. We can directly use Cu2, Cl2 also we can use. And the product we get here is chlorobenzene, and the reaction of diazonium salt always releases nitrogen gas. Okay, this reaction is the laboratory method of preparation of chlorobenzene, and we call it as Sandmeyer's reaction. Have you heard this name?
Yes, sir.
Yes, sir.
Sandmeyer's reaction. Okay. Now, chlorination और bromination का similar reaction है. Cu2Br2 use कर लो. So we'll get Br plus N2. Right? Exactly similar reaction. For iodination, we are using potassium iodide, aqueous medium, and warm. Little high temperature. So we end up getting iodobenzene plus K plus Cl minus को ले लिया KCl, and N2 goes out. Nitrogen always evolves into this. For fluorination, NaBF4 we can use. When we heat this, fluorine, N2, BF3 and NaCl. ये हो जाएगा.
One sec, sir.
Done.
Not literally 1 second. Sir.
Yes, sir.
Okay.
Done, sir.
ठीक है. Okay. Now the third reaction, preparation of this thing, Third is we have done this reaction, so I just write it down. Mechanism we have already seen. Hans-Richter reaction, if you remember, we take RCOAG, right? So R
AG
is
salt.
for alkyl as well as aryl. So when you take this minus plus Br2 in the solvent like CCl4, heat this, you'll get bromobenzene Br plus AgBr plus CO2. Silver salt of aromatic acid.
Carboxylic acid.
Fourth one, we can also obtain from phenol. Plus PCl5. Although PCl5 है, so we obviously get what?
POCl3.
POCl3.
एक product तो POCl3 बनेगा ही ना. POCl3.
And HCl.
And the other one is HCl. 3, 4, and 1, 5. The last method we have by decarboxylation of halogenated acid. So for example, suppose we have this C6H4. It's benzene derivative only. You see this. One side we have chlorine. Other side we have COONA. And इसका decarboxylation we always do with NaOH mostly. So when you heat this, it forms C6H5Cl plus Na2CO3. This is the product we get. One more thing, this CONA and this NaO, this goes out when you heat this Na2CO3. This hydrogen attached over here forms C6H5 and Cl. And instead of this chlorine, we can also take bromine here. Then we get here bromine. So chlorine and bromine ka reaction is very similar. Okay. If one reaction.
So what about the other one, bromination?
Okay.
Hello?
Ah.
Yes, sir. Sir, what about the fourth one, bromination, sir?
Sorry?
What about the fourth one, bromination, sir?
What bromination?
Bromination from phenol.
Bromination on phenol.
Yes, sir.
That also you can do. No, just a second. Bromination on phenol now. No, that is not possible. Phenol bromination is not possible.
Oh, okay, sir.
That would be difficult. The rate of reaction would be very slow.
Yes, sir.
Because of plus M effect of this.
Oh. So 2 minutes. I lost connectivity in middle, sir. Like I had to. I was removed from BT for like 1 minute.
Guys, are you getting it, all of you?
Yes.
Yes, sir. Done.
Done?
No, sir, no, sir. Last halogenated acid. From tomorrow, I'll do handwriting practice. Oh, damn. Shops are closed. Done, sir.
Okay. Now see the few reactions I'm showing you right now. Just copy it down. Just a second. Just a second.
Yes, sir.
Okay. Visible screen.
Yes, sir.
See, there are a few reactions. Is it visible? Okay, see this, the reactions of chlorobenzene. Okay, this reaction you first copy it down quickly.
Sir, what is Dow, sir?
What?
Dow. Dow process.
Done?
Sir, no. Like I was asking, what is Dow process?
Dow's process is only. Chlorobenzene with NaOH gives you first salt of sodium, and with acidic medium hydrolysis gives you phenol. So basically
Yes,
conversion
yes,
of,
sir. What does it stand for?
The name is DA only. It's not like abbreviation of anything.
Oh, okay, sir. Thank you. One sec, sir. 5 minutes. It's too much to write. So 5 minutes, sir.
5 more.
No, 4 more. How? Anil.
Sir,
Hmm.
what is DMF?
What?
In the fifth equation, pyridine or DMF?
The benzonitrile, CuCN, DMF.
Yes, sir.
DMF is a solvent. Just a second. I'll tell you the name. Just a second. Wait. DMF is a solvent. Dimethyl. I'll show you the structure. Just a second. Right. It is dimethyl formamide. I forgot that.
Okay, sir.
Right. Formamide is something which is the derivative of amide. Okay. So like you see, if you take CONH2, HCONH2, it is an amide. I'll show you the structure just a second. DMF is this. HC double bond O NH2. This is amide.
Yes,
So
sir.
dimethyl formamide is the derivative of this. What we need to do, we need to replace the 2 hydrogen of nitrogen with the methyl, this one. So this is DMF, dimethyl formamide.
Okay, sir.
These reactions that I have given you just now, they'll ask you directly, ऐसा ही आएगा ये question. So you must memorize this.
Like directly, sir.
हाँ.
Oh, say 1 minute, sir. What did you fatigue? And done.
Done, all of you?
Yes, sir.
Yes, sir, done.
Huh. Okay, see this here. The last reaction is Wood's fatigue reaction. It's not fitting, it's fatigue. I have written this N by mistake. Okay, when the both thing we have alkyl group, then it is Wood's reaction. This one is Wood's fatigue reaction. The first one is Dawes process. These three are very important. They have asked questions on this. Okay, so the last reaction of this chapter and the most important one for aryl halide is, can I go to the next page? All of you have done? Haren?
Done, sir.
Okay.
Yes, sir, done.
So next reaction, the last one I write down. Friedel Crafts reaction. Write down. It involves the introduction of acyl group, involves the introduction of acyl group. Acyl group is this RC double bond O. This one, this is acyl. Involves the introduction of acyl group or alkyl group. Alkyl group is simple alkyl group we have. Acyl group or alkyl group into the benzene ring in presence of a catalyst. ठीक है? In presence of a catalyst. Done.
Done, sir.
Okay. So when the introduction of acyl group takes place, the reaction is known as Friedel-Crafts acylation. When acyl group get attached to the ring. When alkyl group get attached, it is Friedel-Crafts alkylation. Got it?
Yes, sir.
So
Sir, but
basically,
your voice is breaking.
wait. Let me do this. No, I'll be cutting and cutting.
Venkat, your internet is not proper. I can hear properly.
Oh, okay then.
So Friedel-Crafts acylation, alkylation. So acylation is the insertion of acyl group. Alkylation is the insertion of alkyl group. Obviously, we use a catalyst for this reaction. Like for, suppose, one by one we'll discuss the two. Both are similar reaction. If you understand this, you can do this one also. So first reaction is Friedel-Crafts alkylation. Now in this, we use an alkylating agent and a catalyst. So what we need an alkylating agent and a catalyst corresponding to these agents, right? So suppose the alkylating agent is Rx, alkyl halide, then the catalyst will be anhydrous AlX3. Generally it is RCl or RBr, so anhydrous AlCl3 or ArBr3 we can use. Alkylating agent can be an alcohol also. For alcohol we use an acid for the catalytic purpose. H2SO4 we can use H3PO4, or we can also use some Lewis acid like BF3. Mostly we use H2SO4. Or alkylating agent can be an alkene or alkyne. Understand this very properly. Very important reaction, and there are very small things you have to take care of. Alkene, alkyne. For alkene, alkyne, again we can take acid as the catalyst for this reaction. ठीक है? Overall reaction क्या हो गया देखो? We have benzene. बेंजीन का रिएक्शन मैंने करवाया, फॉर एग्जांपल मैंने कराया RCl के साथ. अब we are using RCl, so what should be the catalyst here?
AlCl3.
Anhydrous AlCl3. Just give me 1 minute, guys. Someone is there at the door, okay? 1 minute, I'm coming.
Yes, sir.
Yeah, okay, I'm sorry. So RCl, so anhydrous AlCl3 we are using, and the product here is we have the benzene ring, and on the ring we have alkyl group attached plus HCl. This is the product. Copy this down. Done.
Done, sir.
Okay. Now you try to understand the mechanism here. क्या होता है, ये जो RCl है, right? This RCl plus AlCl3 anhydrous. AlCl3 here behaves as a Lewis acid. This takes the Cl minus and generates a carbocation, R plus AlCl4 minus. This carbocation behaves as an electrophile for the reaction. After this is the same. This pi bond attacks onto this electrophile, and then H plus goes out to maintain aromaticity, like the thing we have discussed just now, right? Now, since this carbocation forms, So rearrangement is also possible here. Rearrangement is possible. Like I'll show you some examples here. Write down the product in these reactions. CS3OH BF3. We can take this CS3 CH double bond CH2 H2SO4 the catalyst, alkene के साथ acid, and the another one is alkyl halide, which is CS3 CH2 CH2Cl with anhydrous AlCl3. Could you tell me the product in all these reactions?
The phenol. Then that.
Sir, told.
How it is phenol?
Alkylation. Okay, sorry. Toluene. Friedel alkylation reaction. Toluene. CH3 will get attached.
CS3 plus is the electrophile here. So the product
Yes,
of this reaction is CS3 and H2O. In this, the product of this reaction is, the major product is this. And here, the major product is again the same. See, actually here what happens, this alkene, you see this one. This acid H plus comes over here to generate the stable carbocation. Means we have this CH3, CH double bond CH2, acid gives H plus. So from here you get a carbocation which is CH3CH positive CH3. Now this carbocation behaves as an electrophile. So the middle carbon, this is the most stable carbocation we have here. So benzene ring will get attached with this carbon atom, we'll get this. Okay. Now in this one, what happens? This takes Cl minus from this alkyl halide. So CH3CH2 CH2Cl plus AlCl3. This generates a carbocation which is CH3CH2 CH2 positive and AlCl4 minus. Now into this, if we have hydride shift, H shift here, this hydrogen comes over here to give the more stable carbocation which is CH3 positive. Now again, this will attach to the ring, we'll get this compound or this compound as the major compound. Understood? Okay, done?
Sir, 1 minute, sir. Power is actually gone here, sir. We are having a lot of power cuts today. So logged in using another device. So could you just explain the mechanisms again, please?
See what
Aryl?
happened.
Yes, sir.
You understood how the carbocation is generating, right?
Yeah.
This is fine.
Yes, sir. H plus comes in attacks and all.
Right. Now the ring you have and this carbocation. This is a carbocation.
Yeah.
Both carbocation. Is this only this one and this one? Same.
Yes, sir.
This ring will attach to this.
Okay, okay. Okay. And shift, I guess.
Positive. And here we have one hydrogen.
Yes, sir.
To gain aromaticity, what happens?
That one shifts and double bond again. Understood, sir.
Okay.
Yes, sir. Understood.
ठीक है. Next we'll see acylation. Acylation is possible with all these carbonyl compounds. You see, we can take acyl chloride for this purpose. We can take acid for this purpose. These are acylating agent. We can take anhydride for this purpose. We can also take ester for this purpose. All these are acylating agent. And the catalyst we use here, for all this, the catalyst we use is anhydrous AlCl3. Okay. So actually what happens, you have RC double bond OCl with AlCl3. It generates a carbocation plus AlCl4 minus. Now the same thing on the benzene ring, this carbocation attack. Remember this carbocation that forms here, rearrangement is possible there. Okay, so don't forget that. This attacks over here in the same way we'll get this product. And this we call it as Friedel acylation. Okay.
Yes, sir. 1 second, sir.
Remember in the book, most of the book, like board level book, they have given Friedel reaction with alkyl halide only, RX. But all these molecules, whether you have alkyl halide, ring, alkene, right, alcohol, or acyl chloride, acid, anhydride, ester, all these molecules, compounds can show Friedel reaction. Okay, so keep that in mind.
Okay, sir.
Done?
Done, sir. Done.
There are a few points which you should keep in mind for this Friedel reaction, the last thing we are doing. Write down points to remember. First point, write down aryl and vinyl carbocation is not stable and hence we cannot take these two as
These two as?
the component of, we cannot take these two as the component of alkylating or acylating agent. Clear it? Because what happens with alkylating or acylating agent? It forms carbocation, right? So if you take vinyl
Yes, sir.
and ethyl component, so the carbocation forms by these two are not stable at all, right? That's why
No, sir, not stable.
it does not suit for the component of alkylating or acylating agent. Okay. Second point, carbocation forms and rearrangement is also possible. Next, electron withdrawing group slows down the electrophilic attack and hence Friedel reaction is not possible.
Sir, what do you mean, sir?
अगर इलेक्ट्रॉन withdrawing group present है, ठीक है?
Yes, sir.
Drag the electron pair from ortho and para position.
Yeah.
Ortho para position becomes electron deficient.
Okay. Yes, sir.
Electron deficient है तो it won't attract the electrophile.
Electron deficient. Oh, okay. Yes, sir. Okay.
Okay, so
Yeah.
in case of electron withdrawing group, basically FC reaction is not possible. Next time, if the groups like NH2, NHR, NR2, present on the ring, if the groups like NH2, NHR, NR2 present on the ring, then also Friedel reaction is not possible. Okay. Why this is not possible? Because you see, suppose the molecule is this, NH2. So NH2 has one lone pair, and you see we are having a Lewis acid for this reaction, AlCl3, correct? It is a Lewis acid. So what happens? This has tendency to take this lone pair of electron and forms a complex, because it has tendency to accept lone pair, no? So nitrogen can also donate its lone pair to AlCl3, and it forms a complex which is something like this, NH2 plus AlCl3 minus. This hinders the Friedel reaction. So that's the reason here. Okay. Yes.
Yes, sir. Yes, sir.
Now the last thing, compare the rate of FC reaction in these compounds. Friedel graph reaction in these compounds.
So 4 greater than 3 greater than 2 greater than 1. Like based on stability of carbocation.
What carbocation? Where is the carbocation? Carbocation formed by the alkylating agent. No.
Yeah, attach an alkylating agent. It's okay. Like you can assume it to be there. After which it got removed during the process.
See, here we have maximum alpha hydrogen, 3, and maximum plus H effect, right?
Yes, sir.
Alpha hydrogen is decreasing. So here we have only plus I. Here we have plus H, plus H, plus H. Maximum plus H, so it increases the electron density in the ring. Hence, electrophilic attack is maximum here. Correct? So the order of reactivity is this. Plus H dominates plus I. Both are electron releasing effect. More plus H, more electron releasing tendency. So maximum plus H here because we have maximum alpha hydrogen. Hence electron density in the ring is maximum here. Hence it has maximum tendency to accept or attract the electrophile. Hence the reactivity order is this. Any doubt?
No, sir.
So this is it for this chapter. Okay. On the
Okay,
learning,
sir.
there are assignments given. You can solve those assignments. Okay, understood?
Yes, sir. So could you repeat the reason for the? Okay, got it.
What? Tell me. See, देखो यहाँ पे plus H है ना?
Yes, sir.
Electron density अगर ring में ज़्यादा होगा, then it can take that electrophile.
Yeah, yes, sir.
Forming because of this acid and that agent, alkylating or acylating agent.
Yeah.
So you have a positive charge species. कुछ तो electrophile है ही हमारे पास.
Yes, sir.
This electrophile का tendency to react with these rings you have to compare, right?
Yes, sir.
So if the ring has maximum electron density, it has maximum tendency to accept or attract this electrophile.
Oh, yeah, yes, sir.
Correct. So here we have maximum electron density. Why? Because we have plus H, maximum plus H, then
Yeah.
plus H here, and here we have plus I. So order is this.
Yes, sir. Okay.
Any doubt?
No, sir.
Is it clear, guys? All of you understood?
Understood, sir.
Yes, sir.
Yes, sir.
Okay. So we'll wind up the session here. Okay. Learners assignment for alkyl halide is given. You can solve those assignments. Okay.
Okay, sir.
Okay, sir.
Okay. Thank you, guys.
Okay,
Thank you.
sir.
Bye-bye.
Thank you, sir.
Thank
Bye.
you, sir.
Thank you, sir.
Bye-bye.
Thank you, sir.